Hello guys and welcome to Statsbox. So today's topic is variation of acceleration due to gravity with altitude and depth, and we have to show with graph also at last. So today's topic is divided into three subtopics that are: first, effect of altitude; second, effect of depth; and the third one is graph of variation of acceleration due to gravity. So these three are our today's topic. So first of all, coming to first topic, that is effect of altitude. So let's take, this is our earth. This is the center of earth. Let's take it, it's O, and from here to here, this is the radius of earth. And let's take we have to calculate gravity at a point P, which is outside earth, that is above the surface of earth. And let's take height till point P from the surface of earth is h. Okay, this is point P. So I am considering that you must be familiar with the topic of Newton's universal law of gravitation. If not, I have put the link in the description. So let's get started. So we know F is equals to G m1 m2 by r square. This is the formula we derived from Newton's universal law of gravitation. So using this formula only, we know F is also equals to mg. This we know, F is also equals to mg. So using this formula in equation 1, let's take it equation 1, we'll get mg equals to g m1 m2 by r square. And here m1 is mass of earth and m2 is mass of the object at point P. Okay, so let's take this as equation second, and here g is acceleration due to gravity on the surface of earth. So g is acceleration due to gravity at the surface of earth. So now let's take acceleration due to gravity at point P. So there F dash, let's take it F dash, will be equals to G, will be same, m1 mass of earth, that will also remain same, and m2 also remains same, But now the change is, instead of r square, the distance between the center of Earth and the point P is re plus h. So let's sorry for this, let's take it R only. So the distance between point O and P is r and h, so it will be r plus h whole square. Okay, and here f dash will be equals to mg dash, and g dash is the acceleration due to gravity at the point P. So using this in this equation, we'll get mg dash is equals to g m1 m2 by r plus h square. So you might be wondering, what is this m? So this is m1, that is mass of Earth. Okay, let's take this is equation 3. Okay, so now dividing equation, let's divide equation third by equation 2. So now dividing equation third by equation 2. So these are equations, this is equation third and this is equation second. So dividing equation third by equation second, will get m1 g dash by m1 g will be equals to g m1 m2 by r plus h whole square into, and reverse of this, that is r square by g m1 m2. So as you can see, this whole will cancel out with this and this m1 will cancel out with this. So we'll get g dash by g will be equals to r square by r plus h whole square. So now let's take r common here. So this will give us g dash by g is equals to r square divided by, let's take r common, so it will be r here and it will be r, and here will be 1 plus h by r. I have taken h by r because there wasn't r there to take common, so we have to divide by r here, and whole square. So simplifying this, will get g dash by g is equals to r square divided by r square. If we square this r, and it will be here 1 plus h by r whole square. So this r square will cancel out by this, so we'll get g dash equals to, if you bring this g to this side, g by 1 plus h by r whole square. Okay, so now let's talk about a special case now. Special case. So what if this h is very small than r? If this h is very small than r, then g dash will be equal to g, and here will be 1 plus h by r to the power minus 2, and simplifying this further, we'll get g dash is equals to g 1 minus, here will be minus 2h by r. This minus 2 will come here, and this is because of binomial theorem. So we are just concerned about the result. So this will be our result, g dash equals to g 1 minus 2h by r. So if there is question to find G, so you will use this formula, but if in the question it is given that H, that is the height, is very small than R, then you'll be using this formula. Okay, so this was the result that we got. So if you observe carefully, you will see that here G dash is smaller than G. So as you can see, G dash is equals to G divided by some value, that is 1 plus H by R whole square. So it's definitely less than G. So G dash is less than G. So after all, what is the effect of altitude? So here, effect of altitude is that as you can see, as we move upwards farther from the surface of Earth, we see that G is depreciating. So effect of altitude is that as we move above the surface of Earth, acceleration due to gravity will decrease. So what we now know is that the gravity at the surface of Earth is greater than the gravity at some altitude. Okay. So now let's talk about effect of depth. Okay, so now again let's take Earth. So this is our Earth. This is the center of Earth, O. This is the radius of Earth, that is R. So now let's take a point P somewhere here, that is inside the Earth, and let's draw a sphere using this distance, that is PO, as the radius. So this is the sphere we will get. So before moving further, thing to keep in mind is that Earth is made up of spherical shell. So you have to keep in mind that Earth is made up of spherical shell, and these spherical shells, that is under a spherical shell, the gravitational, this is the main point, under a spherical shell, the gravitational force is equals to 0. So as you can see, the point P is here. So this spherical shell, this has no effect, that is the gravitational force at the point P has no effect due to this shell. So only effect that this gravitational force is having is because of this sphere, this smaller one. So let's take, this is height H, or I should rather say this is the depth H, from here to here till this smaller sphere till the point P. So this part, that is OP, here will be equals to R minus h. OP will be equals to R minus h. So we know density is equals to mass by volume. So we will simplifying this in terms of mass, we'll get mass is equals to density into volume. Okay, so let's take this mass, the mass of this sphere, as m dash. So m dash will be equals to density. Let's take density as rho. This is the symbol for rho, into volume. So volume of sphere is equals to 4 by 3 pi r cube, but here r is equals to r minus h, this part only, because the upper shell is having no effect on the gravitational force at the point P. So instead of r cube we'll take r minus h whole cube, so it will be r minus h whole cube. Okay, so we know that we have already learned that F is equals to G m dash, the mass of this sphere, into m, the mass of this point P, divided by, here the distance is r minus h whole square. So here we know G will be same, m dash, we know the value of m dash, so we can substitute it here. It will be 4 by 3 pi r minus h whole cube m, and this rho, divided by r minus h whole square. So this r minus h whole square can be cancelled out with this, so we will be left with 4 by 3 pi G r minus h m rho. So this is the value of F that we will get. So this is the value of F that we got, this one. So here we know F is equals to mg dash. G dash is the gravitational force under that depth. So if I make that figure again, this is the earth, this is the point P, this is the smaller sphere, this is the fixed point O, and this is H, and this is whole from here to here, this is R, and okay, so F equals to mg dash. So G dash is the gravitational force acting here, or gravitational force of gravity acting here. So substituting this value in this equation, we'll get mg dash will be equals to 4 by 3 pi G r minus h m rho. Okay, so let's take this is equation 1. So now if we talk of the gravity acting at the point that is at the surface of Earth, we know it will be mg is equals to 4 by 3 pi G, but instead of r minus h it will be r, so no bracket here, r m rho. So this will be our equation 2. So dividing equation 1 by equation 2, we will get okay, so dividing we will get mg dash by mg is equals to 4 by 3 pi G r minus h m rho, and here also it will be 4 by 3 pi g r m rho. So as you can see, m will cancel out with this m. 4 by 3 pi g will cancel out with 4 by 3 pi g, this one, and m rho will cancel out with this. So what we will get is g dash by g is equals to r minus h by r. Okay, so cross multiplying will get g dash is equals to g r minus h divided by r. So here also, as you can see, this is the expression we will get of effect of depth in variation in acceleration due to gravity. So as you can see here, g dash is less than g. How? You can see g is multiplied by r minus h divided by r. So r minus h is surely to be less than r. So this will give a point value, and then point value when multiplied by g, that will get a smaller value than g. So g dash is less than g. So effect of depth. Effect of depth. So the conclusion is that as we move deeper towards the center of Earth, acceleration due to gravity keeps on decreasing. So as we move deeper, the gravity keeps on decreasing. So now we know that when we move deeper, acceleration due to gravity decreases. When we move ascent, then also gravity keeps decreasing. So acceleration due to gravity is maximum at surface of Earth. So acceleration due to gravity is maximum at surface of Earth. Okay. So now coming to third one, our third topic, that is graph of variation of acceleration due to gravity. So this graph will be, let's plot this graph first. This is our y-axis, this is our x-axis, and let's take this is variation in distance, and this is the variation in acceleration due to gravity due to distance. This is the origin. So now we know that g dash is equals to g divided by 1 plus h by r whole square. This is effect due to altitude. And secondly, we know that g dash is equals to g 1 minus h by r, and this is due to effect due to depth. So you must be thinking, I said before that g dash is equals to g r minus h by r. So how did we get this form? So they are pretty basically same. What we have done is divided this whole by r, divided this by r, that is r by r minus h by r, and this will cancel out and this will result us g dash is equals to g 1 minus h by r only. So basically they are the same thing. So as you can see here, acceleration due to gravity is inversely affected by square of distance due to altitude, and this will affect due to altitude, and in effect due to depth it is affected by I want to say in this g dash is affected by r linearly, that is only by r, there's no square. So the graph, if we take this point, this dotted line as the surface of earth, then first of all here will be effect due to depth, so it will be a linear line like this, and now its effect due to altitude, that is inverse square, so it will be a hyperbola like this. So this is and as you can see in the figure, this point here, the acceleration due to gravity is maximum. So this is how graph of variation of acceleration due to gravity looks like.